Hello and welcome to another session of Excel Programming for Clinicians with me, Dolotson Callon. In this session, I will refresh your memory on a topic that is no doubt already familiar to you, Boolean logic. We will cover how to use the AND operator, the OR operator, and the NOT operator. Now we will see how to use each of these individually, and then finally, we will see how to use them all in combination. Okay, so before we get into the world of these basic Boolean operators, let me show you what we're trying to do. We are going into the world of transplantation, specifically rejection following transplantation. So what we're going to do is we're going to look at the different combinations of conditions that lead to acute and chronic kidney rejection. So one of the variables is antibody-mediated rejection, for which you usually need the presence of donor-specific antibodies and some form of macrovascular injury, macrovascular inflammation. Another aspect of rejection is interstitial fibrosis and tubular atrophy. So we're going to use our AND, OR, and NOT operators individually and together to see how these combination of conditions can tell us whether there is rejection going on or not. We'll start with the AND operator. First, we declare a variable for the antibody-mediated rejection as a Boolean. We declare another variable for donor-specific antibodies as a Boolean, and we declare a third variable for microvascular inflammation also as a Boolean. So let's say DSA is true, so that this patient has got some donor-specific antibodies present. Let's write that to Excel. Let's also say this patient has got some microvascular inflammation. Let's also write that to Excel. What we can now say is that we can call this antibody-mediated rejection if donor-specific antibody is true and microvascular inflammation is also true. Let's write our results to Excel. Let's run this code and see what we get. And as you can see, as expected, if DSA is true and microvascular inflammation is true, then AMR will also be equal to true. So true and true equals true. What if both conditions are false? Let's comment out this code and see what we get. So if DSA equals false and macrovascular inflammation also equals false, what do we expect AMR to equal to? Let's run the code and see what we get. And this time, because both DSA and macrovascular inflammation are false, AMR will equal false. Let's see what happens if you have a mixture of conditions. Let's comment out this code. And let's keep DSA, no, let's make DSA true and keep macrovascular inflammation as false. We would therefore expect that true and false should equal false. Let's run the code and see what we get. As expected, if DSA is true and macrovascular inflammation is false, antibody-mediated rejection will also be false. Finally, let's see what happens if we flip these conditions the other way around. Let's comment out this code. And this time, let's set DSA to false and macrovascular inflammation to true. Let's run this code and see what we get. Again, if one condition is false and the other is true, false and true will always equal false. Finally, let's set both of these to false. So the SA is false. Let's set microvascular inflammation to also equal false. And let's run the code. And as expected, false and false equals false. So the AND operator works exactly as you would expect, given two Boolean values. Next, let's take a look at the OR operator. Let's declare a variable for acute rejection. Let's declare a variable for antibody-mediated rejection and another variable for T-cell mediated rejection. Now we know acute rejection is present if either antibody-mediated rejection is present or T-cell mediated rejection is present. So let's do this. Let's set AMR to true, and let's write that to Excel. Let's also set T-cell mediated rejection to true, and let's write that to Excel. Finally, we know acute rejection is equal to AMR or T-cell mediated rejection. Let's write the result to Excel. So here we're setting antibody-mediated rejection to true, we're setting T-cell mediated rejection to true, and we're saying acute rejection is equal to AMR or T-cell mediated rejection. So if both of these are true, we would expect acute rejection to also be true. Let's run the code and see what we get. And as expected, if DSA is present or T-cell mediated rejection is present, acute rejection will be equal to true. What happens if both of these are set to false? Let's comment out this code, copy and paste it, and set the values to false. With an OR operator, if either of these are true, the result will be expected to be true. If both are false, then the result will be expected to be false. In this situation, we've set both to false. Let's run the code and see what we get. As expected, because both are false, the output is false. So false or false gives you false. What happens if one is true and the other is false? Let's copy this code, comment it out, paste it below, and let's set AMR to true. So now we have one side of the OR is true and the other side is false. True or false would be expected to be equal to true. Let's run the code and see what we get. As expected, DSA is true, T-cell rejection is false, therefore acute rejection is true. What happens if you flip these the other way around? Let's comment out this code, and let's run it again, this time setting AMR to false and T-cell mediated rejection to true. Let's run this code and see what we get. Again, as expected, if one is true the outcome will be true. Next, let's take a look at the not operator. The not operator gives us the opposite of whatever is entered. So let's do this. Let's declare a variable for chronic rejection. We'll declare it as a Boolean. Let's also declare a variable for interstitial fibrosis and tubular atrophy. Let's set IFTA true and write it to Excel. Now let's set chronic rejection to equal to IFTA. So at the moment we've set IFTA to true, we are then assigning that true value to chronic rejection. Let's write out chronic rejection to Excel. Let's run this code and see what we get. As expected, we set IFTA to true. We then set chronic rejection to equal IFTA, and therefore it prints out true. If we set both to false, let's copy this code, comment it out. If we set IFTA to false, and then we set IFTA equal to chronic rejection, we would expect chronic rejection to print out as false. Let's run this code and see what we get. So when IFTA is false, if chronic rejection equals IFTA, then chronic rejection would also equal false. What will happen, however, is copy this code, comment it out, paste, and this time, instead of chronic rejection equaling IFTA, we say chronic rejection equals not IFTA. What do you expect to happen when we run this code? Well, IFTA is equal to false. If chronic rejection is not equal to false, then it must equal to true. Let's run this code and see what we get. And sure enough, when IFTA is false, if we use the not operator and assign it to chronic rejection, it then converts that to true. This works the other way around as well. Let's copy this code, comment it out, paste it below, and change IFTA to true. This time, IFTA is equal true, chronic rejection is not true, and therefore must be false. Let's run this code and see what we get. And sure enough, if IFTA is true, chronic rejection is not equal to IFTA, therefore it must equal to false. Finally, let's see how we use all of these Boolean logical operators together. Let's declare a variable for acute rejection as a Boolean. Let's also declare a variable for donor-specific antibodies as a Boolean. Let's declare a variable for microvascular inflammation as a Boolean. And finally, let's declare a variable for T-cell mediated rejection as a Boolean. Let's set DSA to true and write that to Excel. Let's set microvascular inflammation to true and also write that to Excel. Finally, let's set T-cell mediated rejection to true and write that to Excel. Now, what happens when we combine these? We want to know if we have acute rejection present. Acute rejection is present if there is DSA and macrovascular inflammation, or there is T-cell mediated rejection on its own. So DSA and macrovascular inflammation together with an AND or T-cell mediated rejection is the definition of acute rejection in this scenario. Let's write this out to Excel. Okay, so we've set DSA to true, we've set macrovascular inflammation to true, we've also set T-cell mediated rejection to true. And we're saying acute rejection is equal to DSA and macrovascular inflammation together or T-cell mediated rejection. Let's run the code and see what we get. And as expected, true and true together gives you true. So therefore, true or true also gives you true. Let's mix this up a bit and see what we get. I'll copy this code, comment it out, paste it below. I'm going to leave DSA as true, but I'm going to change macrovascular inflammation to false. And I'll leave T-cell mediated rejection to true. So now we have here DSA and macrovascular inflammation. So both of these need to be true for this to be true. But we now have one of them as false. So the combination you would expect to be false. But then false or true you'd expect to be true. Let's run this code and see what we get. And as expected, true and false gives you false, but false or true gives you true. So I'll leave it as an exercise for you to play around with more combinations of true and false and to include the not operator in there as well. Okay, so I hope you've enjoyed this brief refresher of Boolean logic. This was really mainly just to show you the notation used in Excel and how we combine the AND, OR, and NOT operators together. We'll see you in the next video.